Hello Year 7. Today we are going to be doing conversions between decimals and fractions. So to convert decimals to fractions, this can be done by expressing the number as the numerator and the place value of the smallest digit as the denominator. What that means is if I have the decimal 0.25, the 25 becomes the numerator, and because the 5 is in the place value of the hundredths, we put it over 100. So we get the fraction 25 over 100. This, of course, can be simplified by dividing the top and bottom by 25 to get the simplified fraction of a quarter. Converting fractions to decimals can be done by dividing the numerator by the denominator. So for example, 37 over 100 can easily be written by moving the decimal point using place value. So because it is being divided by 100, we just need to move the decimal point back 2 places, which means 0.37. Some fractions are harder than that, however, so we may need to use a calculator to convert something like 5 over 8. And you'd put that in as 5 divided by 8 and get the result 0.625. Recurring decimals are recurring decimals are decimals that have a repeating pattern. We use a dot, dots, or a bar above the number to indicate a recurring decimal. So below here are some examples of recurring decimals. The fraction 1 over 3 is the same as the decimal 0.333333333, and the little dots there indicate that those 3's would just keep repeating. To write that using our recurring decimal notation that we talked about up here, dot, dots, or a bar, if there is one number repeating, you write down 0.3, and the one number that is repeating, you put a dot or a bar above that number. So you could go 0.3 with a dot, or you could go 0.3 with a bar across the top of the 3. The second fraction, 13 over 11, when you convert that to a decimal, you get 1.181818. So you can see that the 1 and the 8 in the decimal places there is repeating. There's 2 numbers that are recurring. So we write that as 1 point, and we write down the 2 numbers that are repeating. And the 2 ways that we can write that is to put dots above both of the numbers that are repeating, or we could write it as 1 bar going across both of the numbers that are repeating. And finally, 12 over 7, which makes the number 1.714285, 714285. So you can see there is actually a recurring decimal in there, the 714285, and then it starts again, 714285. It's just a lot of numbers that are recurring there. So we need to write all the ones that are recurring. So we have the 1 at the front, the 714285, and we can write it with either a bar going across all those decimal places there that are repeating, or we can write it, so I'll write it down again, 1.714285. To do the dot form, we put a dot on the first and the last number that is repeating. Okay, some examples here to do with this. Convert the following decimals to fractions in simplest form. To do this, you take the numbers that are after that decimal place there, the 2, the 3, and the 9, and you put it over the place value of the smallest digit. The smallest digit is the 9, which is in the thousandths position. So we're going to put it over 1,000. Okay, we should check to see if we can simplify the fraction. So can we divide those numbers to make them smaller? No, we can't. So that's all we can do for that question. Let's try again for part B. The whole number 10, it's going to stay at the front. But the decimal number, the 0.35, the 35 goes to the top of the fraction, and the smallest number, the 5, has a place value of 100th, so we put it over 100. This fraction we can simplify. We don't simplify the 10, it stays out the front, but 35 and 100 can both be divided by 5. 35 divided by 5 goes 7 times, and 100 divided by 5 goes 25, so that would be my simplified answer. Question 2, convert the following fractions to decimals. Now we want to go the other way. So if I can write, or if my fraction is over 10, 100, 1000, then we can just use our place value to help us out. Because these are hundredths, I need the 7 to be in the hundredths position. So that would be 0.17, the 7 being in the hundredths position. In part B, I don't have a denominator that is a lot of 10, 100 or 1000. So I want to try and change it so that it is. So that I can leave the 5 out the front. I could change my denominator of 5 to be a denominator of 10. And all I have to do is multiply that fraction by 2. 5 times 2 makes 10. So 3 times 2 makes 6. If I can do that, I now know that I have 6/10, which means I can convert that to a decimal, 5 for my whole number, and 6 goes in the tenths position, so 0.6. Sometimes, however, we get a question like this, 7/12, and I want to try to make that into a decimal. Okay, now most of the time for most of the questions that you do, you'll be able to do what I did in part A or part B, where the denominator will be able to be written as some multiple of 10. But 12 is not a number that we can multiply to get 100 or 1000 nicely. So sometimes we might have to resort to doing a division to find the decimal answer. And what I mean by that is a fraction, if you remember, means that we're taking our top number, 7, and we want to divide it by 12. Now, we're going to need to know some 12 times tables here to help us with this. We want to do 7 divided by 12. How many times does 12 go into 7? Well, it doesn't. It doesn't go in there at all. It goes 0 times. That means I'm actually going to have to put some decimal places in here to do the rest of the decimal answer. So I'm going to put a few zeros under here so that I can carry some numbers over. So because 7 does not divide by 12, I'm going to cross this 7 out and carry it over into my decimal places. Now I can do 70 divided by 12. All right, just to help out over here with timetables, let's write a few of them down. So we have 1 times 12 is 12. 2 times 12 is 24. 3 times 12 is 36. 4 times 12 is 48. 5 times 12 is 60. 6 times 12 is 72. We're actually going to need a few more than that, so I'm going to keep going. 7 times 12 is 84. 8 times 12 is 96. And 9 times 12 is 108. Okay, so that's just to help those of you who struggle a little bit with your timetables. Remember, you can use your timetable grid to help you with this as well. So I have the number 70. Looking at my 12 timetables, I can't go above 70. So I can't use the 6 times 12 equals 72. I have to use the one just smaller than 70, which is going to be the one that makes 60. 5 times 12 makes 60. So that means that 12 can go into 70 5 times, which gives an answer of 60, which means I would have a remainder of 10. So the 10 needs to go in front of that next decimal place. Now I have 100 that I want to divide by 12. So that's why I did some of these higher ones down here. 100 divided by 12, 108 is too big, but 96 would work. So 8 times 12 is 96. So that means it goes 8 times to make 96, and that means there'd be a 4 remainder. Now I want to do 40 divided by 12. Okay, looking down here, 48 is too big, but 36 is the one I want. 3 times 12 is 36, so it goes 3 times, and it made 36, which means I have a remainder of 4 again. Now, as soon as I keep getting the same remainder over and over again, it means I'm going to start getting a recurring decimal, because 40 divided by 12 is going to be 3 again, and I'm going to get a remainder of 4 again. And I'm going to be getting this 3, 3, 3, 3, 3 going along this line. That means that my answer, my decimal answer for 7 over 12 is 0.58 and 3, which is repeating. So I'll put a dot above it because it is repeating. Okay?